SST or the Agrian systems. So the companies we have with us today, as I just mentioned, we're going to start off with Gary Esselink with Raven, who's going to talk about our Hawkeye system and our Slingshot system. Then we're going to move on to AgEagle with Brett Chilcutt. We're going to present on the Botlink product. Scott Cogdill about the SST, and then finishing up with Nick Morrow from Agrian. So that's the lineup that we have for you this afternoon. Requires action in order to make that data useful. So we're going to start with Gary talking about our Hawkeye systems and our Slingshot systems, showing you how you can actually use the data in the field to apply nutrients, besides herbicides in the field. So with that, I'm going to turn it over to Gary.
Thank you, Martin. So as Martin said, you know, this is the companies that we're going to talk about that we'll bring in and have them speak on their various products. But we'd like to talk first of all with Raven, with Raven Industries. Raven Industries is located in Sioux Falls, South Dakota, as most of you all know. And the model for Raven Industries is solving great challenges. That is what our goal is. We have several divisions, but the ATD, Applied Technology Division, focuses mainly on agriculture. So what I'd like to talk to you today is about the Slingshot system. Now, Slingshot is a product by Raven that places a modem inside the cab or the tractor of either a tractor or sprayer, spreader, etc., and allows us to use the internet to have internet connection via satellites and cell towers or DOT towers to allow for data transfer. I think that's a big thing we have to know. The Slingshot does a lot of things. If you look here, it has high-speed connectivity with the internet. We have wireless data transfer. That's one of the things that we can provide for it. We do fleet tracking, so we know which machines are where out in the field. We provide remote support. So if a system, field computer, etc., is not working correctly, we don't know what the settings are, we can remote in and help set things accordingly and maybe write the issue right out there in the field. We also provide decimeter, RTK corrections is one of the things we can provide, so we go down to inch or less than sub-inch accuracy we can provide, and also links with other companies, such as the APIs that we're going to talk about probably later. The thing that we want you to know is we provide a lot of these functions, but one of the big things that we do is we are the vehicle by which a lot of this data is processed and transferred. It's through the Slingshot system that this all happens. You know, we don't process the data. We can show you a summary of what you've done, but when it comes to actual process, that's when we work with other companies. When we work with the AgEagle system, they are the ones that provide the first data from the aerial overhead view, and from there it goes on, and the field is the field management is probably put together and processed, and through that we can send via Slingshot, we can send it out to the applicator to process it and apply as we want it to be done. And then once it's done, it goes back to probably an API which does the processing, puts it into field data so they can apply it to their later applications, harvesting, etc. All those things fit into it. So like I said, we provide a lot of services with a Slingshot, but what we mainly do is we are the vehicle by which things get transferred. So what are some of the challenges that we have when we're out in the field? Always remember, time is money. So what are some of the things we look at? Well, first of all, there's troubleshooting or assistance with setting up a system. Trying to set something up, and if we don't have any way to communicate back to the main office and we've got an applicator out there, we could travel anywhere from 30 minutes to 4 hours to find out, oh, it's only a setting. Something could be done much better if we could do the remote support like we talked about, or we could just transfer and remote in. That not only works from the main office out to the machine, but also if Raven provides tech support, you can call in, they can do the same thing. Another thing is time spent entering job data into your current business software. It's time consuming the night when it all comes at once. So if you don't have any way to transfer it, and you have to wait for the operator or applicator to come in, and he's got this list of jobs, now it all comes at once. The nice thing about Slingshot is, as the job is done, a button is pushed, it's transferred back to the office, and it can be processed accordingly. So it's done in a timely manner. Another thing is machine tracking, several machines to track. How do you know who to send to a last-minute job? What if something comes up? There's other issues, tracking multiple machines. So if you know where a machine is going to, where they're at, if something comes up lately, well, he's the one closest, I can send him to finish, other than the fact of making a bunch of phone calls. They can tell right off the system where they can go. Another nice thing is software updates. On the field computers, they can be done via Slingshot. That's the new thing that can come out. We just come out with that option now. So that also, if something is done, if you got an issue with something as far as application goes, and Raven has come up with a new update to help facilitate and help work with that issue through a software update, we don't have to wait till they get back or someone doesn't have to drive out there. We can do that over the air right through Slingshot. So we save a lot of time doing something like that. The other part is job reports. So if we're looking at our job reports, let's take a look at some of the things. So if we have time spent creating reports, look how much time that takes. We have to make the report after it's done. We get it in. We have operator efficiency. What is the operator? It can vary from operator to operator, how they write things up, how they complete a job. Is it all done at one time, or do they have a lot of times wait till everything's done, they get back, and they probably do it at the end of the week? Like I talked before, if it all comes in one bunch, now we've got a backlog in the system. It's all coming in at one time instead of at a steady, constant rate and flow. Other thing is accuracy issues when entering data on reports. If it's done by hand, then we have ways that we can be automatically submitted right within the job and the process. We can send that back, the data's collected, we can put it on our Slingshot website, and it can go and it can be downloaded accordingly. If we have something like when our weather station data, which is becoming more and more important as we apply, this is a system that you can put on the cab. It can tell temperature, relative humidity, and maybe mostly important these days with all the different drifting issues that we're worried about with herbicides, it can tell you wind speed. The wind speed is a good thing to have when you're at the machine. A lot of times, otherwise, if there's ever any question, where did they find for that day? They probably check the wind speed at the local airport. Well, the airport could be 10, 15, 20 miles away, the closest one. So those are things we know. If we have something that can provide data right at the machine and it's automatically collected, that's a huge advantage to what we can process and what we can deliver and what we're trying to do. So, another way is multiple ways to enter product names. You know, if you have someone who puts the job together and they can send it right from the office right out to the machine, there's never this traffic in between of who labels the job, what's it going to be, what's the difference, because the operator just receives it, he enters it into the field computer via Slingshot, he finishes the job, he presses a button that the job is done, it automatically gets transferred back. So everything stays and contained within that job and the correct job name and a product name. And like I said, delays getting reports to the office. How does that a tracking inventory? That's another thing. Who did what? Where did it come from? What was the date? If we know it gets done and brought over in a timely manner, we've got the records increase dramatically. I think you can see the efficiency. Probably even office personnel is a big thing, and also machines out in the field. We found with working with good APIs and the way we can transfer data back and forth, that it's amazing how, when it comes to machine operation, there's been even ag retailers who've probably cut back on a machine because of the fact they've become so much more efficient with all the options that are available to them. Creates backlog. The other thing is variable rate application maps. How do we get them to each machine? Raven presents a program called Top Gun, where we bring ag retailers in and we do a lot of training and teaching with them. we talk about our products, but Slingshot is one of them. And I'm still surprised how many, and I'm not saying any of you are, but how many have to send a thumb drive and send it out there with the operator. You know, you think of all the time that takes, or what if there's something with the map? What if the map's not right? What if it's not correct? Now, if that guy is an hour and a half away, there he sits. Time is money. We've done some figuring, and we've figured out that possibly any time a machine sets, it's anywhere from $600 to $1,000 an hour by the time you collect everything. The cost of the machine, time not moving, the tender, everything that goes with it, and how many acres that they've lost because they're not applying, that all counts up. So that time down is a big thing while they're waiting for something. So if we could transfer it automatically from the office out to the machine, look at the time we can save, even if they had to take a little more time to rewrite an RX map up. And also last-minute changes. That's something that happens too. Let's say you have a farmer out there, and he had they sat down with the agronomist. He wrote what the job is and what they wanted to apply. And the farmer comes back, you know, on the day that they're going to come out and apply. So, you know, I've been thinking, I think I'd like to cut it down to probably 80% of what we were doing. Well, now, if everything was written up and he had the thumb drive out there, now what do? Now we have to go back and rewrite, and then we have to drive out there. So those are all logistics things that get solved when you can do something via the internet and over the airwaves. So those are big advantages, I think, that we have when we're working for something versus Slingshot. And like I said, it's a way that once it's done, the data's collected. Now we can go to the APIs who process what we're doing and put that in a usable function for the operator. So, what are some of the things we talked about with the Slingshot? Is remote support. Remote support is available for the Viper 4, the Viper Pro, and the Visio Pro. They all can have a way to log into that system. You can interact with a field computer right when you're in the cab. It's not something that you can do like Big Brother and just come in and take over and take a look. Nope. They have to say someone wants to help you out. The machine or the field computer itself gives you a serial number. You have to put that number, they have to enter it in, and then they can allow the person to take over the remote support. So it's not something that it's ever done. And usually what happens, they push the buttons, you go through that, and by the time you're done, they can disconnect, and they're back on their own again. So that's the nice thing about it. But at least a lot of times when it is something like a simple setting, which happens a lot, you maybe have a new operator, not sure how something's going. What a great tool to be able to keep that machine going the way you want it to. When we have it, a field hub, which is a Slingshot that grabs the internet and processes it. That is required in each machine. But it does, like we said, reduces trips to the field and allows multiple connections. And it has a lot of browsers, and mobile browsers are supported through that. It's usually hooked up and done through via a phone carrier, something like Verizon, et cetera, are the ones we work with. So if we're looking at the future of Slingshot, what do we got coming up? You know, the future of Raven technology knows no limits. But what we're talking about is data initiatives and strategy. So telematics and monitoring data. So what's telematics? Telematics is the technology that, just for those who don't always know what telematics is, it's a term that's out there, but it's basically the technology of capturing data from the machine out in the field and sending it via the internet real time to another place. And that's the idea. That's what telematics does. So that is, we're monitoring data. We give logistics and fleet data. So that's part of it. So something with Ag Retailer Initiative Development, we're going to have those work orders sent directly to the field computer for retailer software. We have machine-to-machine sharing, which is kind of nice. So you get to the end of the day or the end of the week, and rain is coming, and you've got this big field, and you've got someone else who can come and help. We can share that machine data, and we can finish that field quickly. Like I said, real-time remote view of coverage. We can see what's happening. Logistics and fleet management allows more through a la carte subscriptions. And part of the thing is, you know, the data is that what we're doing, we can collect the data if we're allowed to. It's not like, once again, a Big Brother, but if we have a system, we can collect data like on a steering system. and say we have let's say we have, case machines, case tractors, and we want to know how they are performing in the field. Well, if we get several of them, 3, 4, 10, 15 of them, and we can gather the data and see how they're performing, we can fine-tune and come up with the correct tune functions to make sure that it performs correctly as we want it to. It used to be in the past, if we have some issue, we'd say, well, press the button on the machine, and you have to put a thumb drive in, and we'll log data, and then we'll get it back, and we'll analyze it. That's all going away now. We can log the data as we go on the fly. That all comes with us. So that data is available, and we can go on, and from there we can go right into what we're looking at, and we can process and come up with a solution that much quicker than we have in the past. So those are some of the things that we were looking at as far as what we hope to tie in with the Slingshot as we're going today. So just a couple quick things on some products. Raven Applied Technology. If you know that, we're devoted to feeding the world. Raven Applied Technology has been around a while when it comes to flow controls and application. That's one of the things Raven has been known for over the years, and we continue to try and strive to be the leader in that field. So one of the things we'd like to talk about that we want to see is a Hawkeye nozzle control system. So what is that? That's individual nozzle control at each nozzle on a sprayer. So that means that the rate, the pressure, and droplet size remain constant as the speed changes. Everybody knows we've got probably on a nozzle, you probably have a 4 to 5 mile range, and if you go higher or lower, the spray pattern changes. Through use of an electronic PWM valve that's pulsing and maintaining constant pressure, we can take that same nozzle and we can expand that range from 4 to 20 plus miles an hour, and your spray pattern stays the same. And what we're doing these days as far as application and the types of chemicals we're using, that's of extreme importance. The rate is calculated based on the individual nozzles, on or off per section. So we can do it by section. We can reduce spray drift, obviously, because our pattern doesn't change. We have turn compensation. Turn compensation allows us, so when you go around a curve, the inner part, everyone knows the inner part will apply more, and the outer part will under-apply. Well, we can compensate for that and make sure when the outer part is going faster, we will produce more chemical and more spray to apply and compensate for that faster speed on the outside versus the inside. The as-applied map reflects individual nozzle application, so we don't go by section. When we go individual nozzle, we can do that. And when we're fewer nozzle changes, the nice thing is people say if you have a 120-acre field, a lot of times because of the overlap, it would be probably application acres would be 121, 122. You can do on a 120-acre field, roughly you can cut that back an acre or more. So that means not as much application goes on. Quicker on-off times. The nozzle itself, because the PWM valve makes that compensation. And finally, real quickly, another thing I think that's come into play with the dicamba use is direct injection. Some of the advantages we have, there's no tank mixing involved. It's just pure chemical being injected into the system, and the tank itself is pure water. We can adjust chemical concentration as you go, rather than waiting for the entire tank to empty. Greater flexibility in applications to tackle weed resistance and other challenges. We know that's a big thing that's coming up, and that's allows we can do a specific chemical for specific crops. We save time rinsing the main tank when changing chemicals. That all takes time. Reduced waste from unused product. We're right on the money. We don't have to have like 5 gallons left in the bottom of the tank when we're done. Reduced chemical exposure is additional safety. More accurate application, separate products for field records. That's one of the things we're looking at. You can say I put this much mixture in my tank, but if you have a separate product that says I put this much water on, and another product says I put this much chemical on, so we're covered. We know what what the use of dicamba herbicides makes a big deal, and that includes using buffer zones, etc. And finally, for those of you who use NH3, we know using the N-Serve, etc. That's a big thing that also is saved on the NH3 equipment as well. So those are just a few of the things that brought up with the Raven products as far as how it fits into ag retailer and as far as the data goes. that's what we're looking at in regard to processing the data that we will find out more about as we go on. So with that, I'll turn it back to Martin, and we'll get going at the next set of presentation.
Very good. Thank you, Gary. Appreciate that. All right. So we saw pretty quickly how data can be managed, how it can be moved around from your office to your machines, between machines. So there's a lot of advantages to the Raven equipment that Gary talked about in managing the data that we're now going to start talking about collecting and processing and preparing for your field. And lastly, the products that Gary talked about at the end, the Hawkeye and the injection, it ties in very well with our theme of putting the right product at the right place at the right time and at the right rate to do the job that you need those chemicals and those products to do in the field. So with that, we are going to move into AgEagle and actually show you how that data is collected, how the product, how the AgEagle collects that imagery, and start the process. So with that, we'll turn it over to Brett.
Thank you, Martin, and thank you, Gary, for the great lead into how all this technology is going to help today's farmers. So I'm Brett Chilcott from AgEagle Company. We're based in Neodesha, Kansas. We were one of the first manufacturers to build drones for specifically agriculture. And there's a lot of other uses for drones today, but the biggest return on investment today is in agriculture. And that's what this entire event is about. How to apply the right material at the right place, at the right time, and the right amount. So what do we mean by the 4 R's? We're going to cover how to get it from the farmer or to the farmer at the right location, to the right supplier, the right rate. The days of applying the same rate over the entire field and wasting some material and applying not enough in other areas is over. At the right time, we don't need to wait on satellite imagery anymore, or last year's field data, or the yield may be old. So this technology helps them put it at the right time, and more importantly, at the right location. And along with the right location is skipping the areas that's not appropriate as well. It'll help us do that as well. So what do we mean by the right source? As an ag retailer, you're in the driver's seat as the source. This technology can help you grow and be a leader in precision ag. And what do we mean by that? If you're an ag retailer or co-op, we've heard some significant return on investments of using this technology. So by using this technology, it shows your customers that you're a leader in the technology, that you're a leader in precision ag, and you care more than just selling the inputs. You care about helping that grower apply the material at the right location. Some co-ops and ag retailers have reported a significant return on investment as short as just a few months with this technology, because they're selling it or they're packaging it as a bundle to help the chemicals and inputs be put at the right place at the right time. So at AgEagle, we manufacture 2 different systems. The one system we're going to feature today is the hand-launchable RX48. We have 2 systems. The RX60 that Raven also offers is launchable with a catapult launcher. And today we're going to feature the hand-launchable system. Both sensors are sensitive to crop health, and we will see how these images that are collected is processed through our partner Botlink from Fargo. So we get a lot of questions is, why do I want a fixed-wing drone versus the inexpensive multi-copter that my son or daughter has that they purchase from Best Buy or Walmart for a few $100s? There's a big difference. Here's one of the differences. Consider as a grower, we assume that you're going to be farming over 40 or 80 acres or so. A typical small Chinese drone is capable of 30 to 40 acres. We've heard some people being able to do 80 acres with a small multicopter. But because they're a multicopter, you have 4 motors running at the same time. They're expelling a lot of energy just to sustain in the air. On the AgEagle systems, they're flying wings like an airplane. We only need 1 motor. So because of that, the RX48 can cover 100 to 200 acres. We have done a lot more than 200 acres. But let's just say if it does 100 to 200 acres in 1 battery charge. So your time is more efficient there. And the RX60 is a little larger system. It's capable of 300 plus acres. So how does all this technology work? How can we put a sensor in a small drone and detect the health of the crop? How we do that is a sensor that's measuring the amount of reflected light that's reflected off the leaves. I've said in 2-day seminars to explain what I'm going to explain in about 30 seconds here. But the more reflected light off of the leaves near infrared, the healthier the plant is. When a plant is under stress, for whatever reason, if it's nutrient, moisture, insects, it becomes stressed. And our sensors can detect the difference between healthy plants and weak plants. So let's talk about the right place. How can this technology help you as a grower or an ag retailer put the chemicals and nutrients at the right place? So on the left-hand side is an aerial image that was created from the AgEagle system and processed by our partners Botlink. It's real simple to interpret this. Green areas is where the plants are healthy. Red and black are areas that they're poor. And so by importing these images into your favorite ag management software, you can create a prescription map that puts the chemicals in the right place. Whether your machine uses a grid map or a contour map, it's irrelevant. Both of these can be created from our technology. Let's talk a little bit about the right time. This technology is not the only technology, remote sensing out there. Of course, we all know that we have satellites and manned aircraft. The thing that the drones can do that technology cannot do is it increase the resolution from 60 feet or so down to a few inches. So it's much more accurate. But also, consider this. A satellite is going to be passing overhead every so many days, okay? What if we have cloudy skies like we have today? You're going to get the tops of clouds. So the right time could be today, and we need to apply material tomorrow. On a day like this, you wouldn't want to do it in the rain, but complete overcast, you can do it. Regardless if it's partly cloudy or sunny or overcast, the AgEagle technology can do it. And also if it's windy. People ask all the time, how much wind can you fly in? I said, well, I don't know. The most wind we've ever flown in is 42 miles an hour. So they are very robust and they're made for ag. Let's talk a little bit about probably the Achilles heel of remote sensing and something that a lot of competitive systems will not talk about. This is a typical spring day in Kansas. We have low ceilings, low clouds, but it was partly cloudy, and the corn plants were at about 4 inches tall. And my title is, do you really have time to come back and do this when it's sunny? A normal processed NDVI or NIR image looks like this. The green areas where the sun was out, the red areas is where it was cloudy. You would not want to create a prescription map from that. That's bad data. Botlink and AgEagle teamed up together to create this system. We call it NIRX. It removes the effect of the shadows from the cloud. It's a reflectance type image. So you can see a drastic difference in these two images. The image on the left was unprocessed. That's typically what you would get out of any other drone on the market. On the right-hand side is what AgEagle does, is we remove the effects of clouds. So we answer that question. What is the right time? It's when you need to collect that data. And with an AgEagle system, you can collect it virtually any time other than when it's raining like it is today. At the right rate. You can create whatever type of prescription maps that your technology, your precision sprayer may need. A contour map or a tiled map on the right-hand side. Basically turn it on or off or apply it in whatever rate is appropriate. This is how easy the system is to launch. And you basically shake it and release. Martin is pretty good at that. We'll show that one more time. It's very, very simple to operate. So the drone will automatically take off, it automatically flies the mission, and it will automatically land. This is a typical landing. You tell it to land wherever you want. It may be at the edge of a road, it may be in the crops, but it does this all automatically. Well, the video paused there, but it lands right at the edge of the road there. See if it'll play one more time. There, it paused again, but it lands right at the edge of the road there. So automatically takes off, automatically flies, and automatically lands. So, that's what the AgEagle technology does with the help of our partners and the other software companies in this room. We help you apply it at the right source. You, the ag retailer, become the right source at the right rate, the right time, and the right location. And I look forward to your questions at the conclusion of the meeting.
All right. I think you saw there, he put into pretty good terms some of the differences between aerial imagery using satellites, airplanes, or the AgEagle. And one of the big advantages of collecting the data with this type of technology, and in particular the AgEagle, is it puts that control in your hands of when you collect that data. Like you said, a cloudy day like today in South Dakota, if this was when the satellite was scheduled to take the images of your field, you wouldn't have any useful data that you could use. If you know you're going to be doing an application next week, well, fly the field today when you want to fly it to get the information to make that proper application in your field. So again, it puts the control in your hands versus somebody else's hands of when you collect that data and actually make good use of it. So with that, we're going to turn over to Botlink. And Botlink is the company that takes all those images. Now, recently in some flights that I've done, flying 160 acres, 1,100 images to 1,600 images, and taking all those pictures and putting them together into one image or one data set that you can actually use in your field to make those decisions. So with that, we'll turn it over to Will.
You're welcome. And thanks, Brett, for giving us a little information on the AgEagle. AgEagle is really our partner that we've kind of gone to kind of bring this drone technology to you, and we're really the central hub for all your drone data. So we do all the flight planning and flight control for the AgEagle, make it really easy to use, and then do the image processing and deliver it to your ag management software that you're going to use to make decisions and kind of get to work. So just end-to-end system. I'm Will DeHull. I'm the head of flight operations at Botlink. I've been working for about 2 years now. So I do all the flight testing and quality assurance and really anything related to the drones. I get the fun job. So, and the beauty of the drone technology is the same day prescription application. So we can get in the air quickly, fly the same fields repeatedly, process that images, and make decisions off it and apply chemical or make whatever changes need to happen. So the kind of three main parts to Botlink, and I'm going to try not to repeat myself too much on what Brett touched on earlier, but we have the flight planning app, so just a super simple automation of planning your flights. Just draw the shape of the area you want to fly. Botlink automatically calculates a flight path and takeoff and landing for you. And then we do the map processing, so we can generate both the NDVI images that Brett was talking about, as well as the surface model. So we can generate contour maps and everything for your field if you want to look at drainage issues or kind of just high and low points. And we also do high definition maps. So depending on what camera we're using, we can also have just high definition maps that look like satellite imagery, but are, you know, from today or whenever we flew it. And then our cloud platform is all about processing that data, making any measurements or exports of that to any software that you might be using to make any changes. So the quick Botlink workflow is capture the images, distribute it to the Botlink processing, and respond, make decisions. So just keep everything as user-friendly as possible. We don't want you having to learn how to fly a drone, learning how to stitch all these images together yourself and make decisions. We want to automate that and make it as quick as possible. So the mobile app is really focused on keeping things simple. Simple flight planning, you just draw the shape of the field. The drone takes care of the rest. You can monitor it during flight, make changes, and save your flight plan. So if you're flying the same field, you can just repeatedly go out there and load up the plan. You don't have to plan every time. So just kind of keep everything quick as possible. Get in the air with as few clicks as you can. And then connected drones. So AgEagle is really our partner in the ag space and what we really like to stand behind. And one of the offerings that we have with the AgEagle as well is the option for cellular connectivity. So we have a 4G LTE device on board that allows you to upload those images as it's flying to our network. So by the time the aircraft's landed, we're already processing those images and can get you that processed image back as quickly as possible. So you don't need to pull an SD card, throw it in your computer, and do any system like that. And then you do have the ability to also pull that SD card. So the 4G is an option. A lot of our users obviously are in areas that not necessarily available, but try to give you the options that you might be looking for. And then the cloud is where we're doing all our upload and processing. So just selecting the images that you've captured with your AgEagle, upload it to Botlink, and here is where we generate these maps, allow you to measure and annotate on it, manage all your fields and all your flights, and then export to different apps. So SST, for example, have an automatic export option. So any images that you upload to Botlink, you can set up to automatically export to SST. And then the maps are compatible with really most of the ag management software. Yeah, try not to repeat myself too much, but really the high definition maps, the vegetation index, the kind of red to green maps that give you the highlights of where healthy plants are and stressed plants are, the surface models as well as 3D models. So it doesn't necessarily apply to most people in the ag space, but we do have the ability to generate 3D models, whether it's a ditch or just your field and you want to see what the contours of that field is. And then the exports as well. So the files that we're generating, these map files, are compatible with most of the industry-leading software. So one of the main use cases of Botlink and drone technology is monitoring your crop health, generating prescriptions, scouting, irrigation, really all these different things that you can see on the slide here. Just helps you, doesn't necessarily keep you out of the field, but gives you a good map to see where issues might be, so you can save time on actually walking the whole field or driving a four-wheeler through that and trying to figure out how far an issue might extend to. So go over a couple quick case studies that we ran here, and some of the colors might be slightly off on this slide, but this was a situation where nitrogen had been applied in the fall, and the customer was hoping that that was going to last through the rainfall in the spring. Unfortunately, most of it was lost. So we can see where some of the red parts are here from that area is where we had low nitrogen content. So we ended up flying the AgEagle over it. We were able to scout using the onboard NIR sensor and pick up those red zones and find that those were areas that were deficient in nitrogen. And that same day, write a prescription and apply some urea to those zones. And then here's the map from a month and a half later. Significant improvement. You can see that all those red areas are pretty much gone. So, you know, the progress was fantastic on this, and just very quickly we were able to make some good updates. Yeah, customer said it's the best the field has ever looked. And I think, where's the number? Yeah, so the 30 acres that were otherwise would have been written off, now the same quality as the green areas. So a huge return on investment there for the farmer. Was able to really save some of those areas of his field. And another case study on some variable rate seeding. So we had flown this every 2 weeks, and then applied it with last year's yield map to create a variable rate seeding prescription, and then kept the rest of the field management the same. And even though 2016 was the hardest year that this field has ever seen, it had a ton of issues happen to the field, but it still yielded 11 bushels an acre higher than ever recorded. So we were able to really optimize what our field was able to do, just using that satellite imagery in conjunction with the yield map. So just having that aerial data that we can rely on, high resolution, like Brett touched on with the satellite imagery, we're going to get higher resolution than that. Now we can get it when we want. So if clouds had been over top, we might not have been able to use this data. So, and then I can quickly go through how it works. So simple flight planning. This is the drawing the box that the AgEagle is going to fly. So really we just draw the shape of the field boundary, and then the back and forth is the flight path of the aircraft. All your flight plans are saved, so every field that you're flying, you can save it in Botlink, and every time you go out to your field, just pull up that same flight plan. You don't have to plan every time. Set the wind direction. So this is part of the automated process that we have. So this allows us to build those auto landings and set the direction that the aircraft's going to fly in, as well as airspeed. So this is just some calibration stuff, not super important for presentation. And plan the takeoff. So this is just kind of showing you how easy it is to set both where the aircraft's going to take off from and where it's going to land. So the little landing spot in the triangle is where the aircraft's going to land at, and the circle directly to the top of that is where it's going to loiter down from altitude. So just making it as easy as possible. This is the screen you see when the aircraft is flying. So like Brett said, it's super easy to take off. You upload this mission to the aircraft, shake the plane, let it fly, and then you just monitor its progress during the flight. So while it's flying, you can press, there's a little home button in the bottom right, allows the aircraft to circle and come back to that pre-loaded landing point. And then you get a lot of telemetry information, what your battery's like, and connection strength and things like that. Yeah, so just keeping everything super simple. I know there's kind of went through a lot there, so if you have any questions on really how the Botlink system works, we're trying to be the main hub of getting your drone data from your drone to the ag management software that you're using, and easily processing it, keeping you from having to buy expensive aircraft for flying, expensive computers for processing. Just make everything both affordable as well as high quality. So that's about all I have. In the back.
You can see in really bit of detail how easy this can be with. Setting up the mission. I've been flying AgEagle for about a year and a half. I've been flying the 48 now for about 4 months. Setting up the missions is extremely easy. A lot of people can be intimidated by drones and flying them and managing them, setting up the missions. This system, with the help of Botlink's mission planning and aircraft control is fully autonomous. So you don't have to be a skilled pilot to operate this. They've made it very intuitive, very user-friendly. It's a great system to operate. So Botlink, nice job there. Uploading the files, as Will mentioned, you can do it through the cellular network, which both Eagles are capable of. And with the experience that I've had recently flying these, as I mentioned before, 160 acres, 1,300 images. Those images can all be uploaded to Botlink's system before this thing even lands, which is pretty impressive. And we've had some flights where we've flown the field, and on the way back to our office, the processing takes place. When we get back to our office, we have a finished stitched image that we can actually start working with within an hour of being back to the office. So a pretty impressive system. So with that, we're going to turn it over to Scott with SST, and we're going to talk about starting to work with the data. Now that it's been collected, now that it's been put together into a usable format, into a map, what can we do with it? And so SST will start talking us through that of how to work with the data and start applying it into your operation.
All right, thank you, Martin. As Martin said, my name is Scott Cogdo. I'm Western Corn Belt Account Manager with SST. I'm located in Huxley, Iowa, right in the center of the state. Been working in agriculture my whole life, farm as well. But anyways, really going to focus on how to utilize imagery as it comes down, how to make some decisions, how to utilize it in field, how to utilize it in season. And I'm going to really mainly focus on just using it in the field itself with an app that we have called Cirrus. When you look at really one of the main points going forward is we talked about before the integration with Botlink and AgEagle. AgEagle is the background piece to our system that has schemas, standards, databases to allow data to move within our own system, within other systems to allow you to share out the growers, your own agronomy team, whatever that may end up being. And so when you look at how that works, I mean, obviously we're all bound by time and not having to manually handle data, as Gary talked about with Slingshot and some of the other pieces, it's very similar. Not having to manually move the data, import the data, handle the data to allow it to work seamlessly real time. So when you look at this, the integration between Botlink and AgEagle, what you end up happening there is an authentication process that will happen within Botlink. So you would get signed into your Botlink account, and what would end up happening is, I believe it's in the settings and all that, and you can select the AgEagle portion on the bottom there. And when that happens, you sign into your AgEagle account, and it's going to ask you, AgEagle would like permission to access, certain things within Botlink. And within that, what ends up happening now is any boundary that you've got in your AgEagle account is now available for Botlink to use and can be moved over. And so if you've done any sampling, scouting, soil, yield data, fertilizer recommendations, anything that you've done in the past that you've already got this grower's field in, now becomes automatically available in the Botlink platform. Now with that as well, means that, so you can send that out, move it into Botlink, and then it can go ahead and when Botlink is done doing their processes, that means now the data can be moved right back into your AgEagle account, and you can have it readily available in the app while you're, theoretically still in the field. So once you've gone through that process, a lot of questions kind of get brought up of what do we do now? What do we do with the data? When you look at certain things, I think a struggle that has happened in the industry is what can we do with this? What's realistic? What's timely? What can we do with the data? This is a very simple slide. It's something. It sounds very simple, very basic, but something as simple as just viewing the base image and just using it to ground truth to make sense. Does it make sense what you're looking at here? Being able to edit some of it to change variability, to truly see what is happening. It can be your base discussion point with the grower. Do these areas make sense? are the red areas, what do you believe is causing these red areas versus the dark areas? Is it something that we can try to intervene with in season? You know, that's really, as I say, it's something very basic, but just viewing and discussing the base image is probably one of the main starting points that I think is dramatically overlooked within the industry. As we're looking within these areas, there's obvious reasons that we have going on within these colors. And say it's compaction, say it's man-made, say it's physical that we have bad areas. Those are things that we cannot intervene with in season. And those are things that mistakes that happen in the spring, mistakes that happen in the fall, whatever it may end up being, and we know that. But if we're looking at it and we're deciding these are things that we can intervene with, now we've had that discussion, we decide we need to use this base imagery to go out and try to find out what we can do and see what is going out there causing the variability and finding out what it is. So with that, as we talked about being able to move it through AgEagle stuff, you can set that up, share it back with agronomists, growers. You could have it be where you could have a person, you know, out in front of you or real time, out flying fields, and it's syncing back to a set of scouts, samplers, whatever it may end up being, and it's happening in real time as you can go out and do some of these things. So we look at it and we decided, you know what, this is something that we need to go investigate. It makes sense, you know, or it doesn't make sense of why that's there. So let's go investigate it. Oops, I apologize, I hit the wrong button. One of the basic ones, obviously, is scouting. And I really won't spend a lot of time on scouting because it's, you know, pretty well-known concept. You know, you can use that image as a background to go out and direct where you need to go check, find out what's causing the variability, what's causing the red areas, what's causing green areas, what are we looking at. Now, obviously, it's very seasonal and crop specific. If I'm looking at a image of a cornfield on June 1st, is going to be a much different experience than when I'm looking at a field of corn at tassel. If I'm looking at a field that's been flown 1st of June as well versus one that's later on the summer, I may be looking on at different things. Am I looking for weed pressure areas, chemistry breaks, or maybe I have, you know, breaks in weed pressure where all that we can go start scouting and start making a little better plan of what's happening. So really it's one where, you know, using it to send your scouts, especially if you've got, you know, interns, whatever it may end up being that maybe aren't the most experienced or don't know the field all that well, you can really utilize an image to start sending them to the areas that they need to start focusing on within the season. Really, you know, the one thing that a lot of my discussion will be around here is the use of imagery for in-season management. And in-season nitrogen management, I apologize. And so as we talk about nitrogen, it's obviously a very large industry discussion right now about reducing nitrate loads, utilizing nitrogen better, being more efficient for both the grower as well as just everybody. So one of the things too is to be able to take this recommendation or the image in itself and load it up in the background and use that as where you want to direct your nitrate sampling. And so we can sit there and determine we've got better areas here, we've got worse areas here. And one of the points about that is you can use that and go across the field, and as you are pulling the nitrates, you can decide, is this orange the same as this orange? Are we dealing with same texture? Are we dealing with same things? And if we are, we can group them. But if we're not, we may need to start handling some of these areas a little bit differently. This field is actually one of my own. Isn't exactly the best picture because normally we'll have a red spot down here where this is really saturated soil and this is pure sand. And, so it's one of starting to understand what are we looking at, what's causing the red in those areas, what's causing the stress in those areas, can we treat them the same, can we handle them differently, what do we need to be doing? When you look at this as well, you can look at that in combination with some other base layers. As I'm out here and I'm seeing something that pops up on this, pull up an as-applied planting map. Am I seeing something that's strictly, once again, is it human created? Is this a physical variation? And so it's about utilizing the imagery as another tool to help fine-tune what you're doing in season. So when you go out, actually I'll pull that back up. So really as we go through, you pull your nitrates, you can decide if you want to do, subsoil, a single depth from 0 to 12, 12 to 24, however you want to set that up, and get those nitrates pulled, get them off to the lab. As we get that back, now it really kind of turns into a couple pieces of what do we want to do next? And we've got the results back. We see there's deficient areas. Side dress was a planned event. And so we have this, scheduled in. We made time for it. So we decided how we want to handle the nitrogen recommendation. How do we want to handle the creation of that recommendation? And so we can do some more of the simplistic basic rec creation where we're looking at it and saying, okay, we've grouped the yellow areas that I've got highlighted there. We're all sampled as one, and we're just going to say anything that was a yellow is going to get 15 gallons per acre. Anything that's green is going to get, 12, 20, 25, who knows the number, based upon what comes back. And so really you're deciding, am I going to assign it to an entire classification, which would be the color itself, or am I going to assign it to a specific zone? We talked about red maybe not being red. If red is drown out versus sand, you'd probably have those two red areas as different, so you would treat those specific zones independent of each other. So that would be one way of creating an in-season nitrogen recommendation that's a little more basic around the actual applying it to the zones that you've pulled and just using some recommendations that either come directly from the lab or come from a university or whatever it may end up being. Another option is to create more of an advanced nitrogen recommendation where that image that you've used to go out and pull your nitrates is utilized to get your results back, and now you've taken those in-season nitrate values on top of other multiple layers within that field to create a more advanced, more specific recommendation where we're using layers such as potentially yield zone, some soil texture, organic matter, slope, previously applied products, looking at some weather factors, whatever it may end up being. One of the benefits of that is there's some greater flexibility in editing as you get through, since we are dealing with more of a surface recommendation versus a zone. We can have much greater flexibility on how we're dealing with total overall percentages, total products, as well as greater flexibility in changing products real time within our system. The way our system works with the advanced recommendations is delivered as a nutrient REX, would be delivered as nitrogen 100% before it goes to the field if you need to make that change from UAN to urea, to anhydrous, whatever it may end up being. It gives you a little more flexibility on the go. So really what that does is allows you to take that image, go out and pull where you feel that you need to have your directed nitrates, and then utilize that as part of a broader picture of a pre-planned nitrogen event in season. So really the final thing on that, I apologize a little more on some of the advanced recommendations. And then really, the final piece in all of this is more of a report card, an end-of-season report card. The end-of-season stock nitrate test. And anyone who's ever had to do these before knows it's not the most enjoyable thing in the world to do, but it is something that we can take that original base image that we used, that we flew back in, say, June, and pull that back up that we used to direct where we were going to pull our nitrates and use to apply nitrogen. We can use that exact same image and some other factors of the recommendation, whatever else we use to put nitrogen out there, and go out there and actually pull our stock nitrate tests and send those off to the lab. Now, obviously, anyone who's ever been around stock nitrate, there are some factors of what can cause the variations in the numbers, but it gives us a look at a report card. Do we have excessive nitrate in the stock? That means, we probably over-applied a little bit this year. Nothing we can do about it this year, but it gives us a little better understanding of what we can do moving forward. Or are we seeing stock issues show up as before we're getting ready to combine, we're seeing stock issues show up? We can go pull some stock nitrate tests, and is the plant starving itself, or is it just a symptom of a poor stock quality on a plant? So really, when you look at it, it's more wanted to focus on how to utilize it in season for nitrogen. Obviously in a corn situation, very specific to my own area and all that. So that's really all I have for today. And I believe Nick will be coming up next. So thank you.
So we're moving into the phase of actually applying the data in the field, making management decisions based on that data, and actually using it in your field. And so we're going to turn it over to Nick and look at another software system and see how that data can be used. So with that, I'll turn it over to Nick.
My name is Nick Morrow. I work with Agrian, and I'm the product team there, so I'm in product management. I came from the remote sensing world with and on the aerial side, so I have a little bit of experience in this area. Do I click on it? Do I click on it? Oh. No, I'm the only failure. Huh. That's cool. There you go. Okay, so it's better. So kind of from our view and my view, that imagery tends to give people the right place, and that's kind of where it stops to begin with. It tells you where something is, but not necessarily what, how, why, and what to do. So from a 4R perspective, it's really kind of where to begin with. But when you add an advisor in there, that's where you can bring in the rest of the 4Rs. So we kind of look at all of our tools when we want to build a tool that allows the advisor to, provide value to the grower and to their company and so forth. So, with that advisor, you can get the right, in scouting, you get the right rate, right source, right time. And then, of course, with scouting and our new fancy devices and so forth, we can capture all of that, and then, again, more algorithms to kind of add value to that advisor. But in the end, we kind of view the advisor in the center, imagery showing you where, the advisor is kind of closing that gap. For me, imagery, kind of two pieces, just our strategy on imagery. There's really sensors and vehicles. So whether it's a satellite vehicle, a airplane, Cessna 172, or an AgEagle drone, they're vehicles. Sensors are cameras or synthetic aperture radar, all the new cool stuff you probably hear about. They're just sensors and just vehicles and their tools to solve a problem. So whether it's 20-meter landside data, 1-meter aerial data, or 2-centimeter drone data, that's there to solve a tool, and you got to look for the right tool to solve the right problem. So what I want to do is take through a couple of a cropping cycle and just kind of give a couple of examples on each piece of that cropping cycle. So for right now, I kind of have start with harvest as the next season, and we have some challenges: weed pressure, soil sampling, flooding, just general farm management, and so forth. So I want to kind of go through a soil sampling example. Scott has his own farm. My dad sold his in 1985. So all of my examples are from South America, and I made a deal with the South Americans. So, but you know what? They farm the same way, more or less, just a different language and less valuable money. So imagery is a great way to do soil sampling for zone sampling. So building out your management zones with imagery. Down there, the cost of sampling is very, very high. So we're $7 to $10. Brazil is $80 to $100. So you can imagine they want to reduce the number of cores. So imagery basically looks at variability and creates management zones, and they sample less than within those management zones and apply that to the rest of the field. So this is the case, I don't know what imagery source it is, but it basically gives you the general variability of that field at max variability time. And we build a management zone from there. So I have 3 management zones, so that soil sampler is going to go out and collect 3 to 6 cores within that field and send 3 cores to the lab instead of 30. So here's an example of it being on an iPad device. So this is where the technology kind of creates a lot of value for that user. They bring in that imagery data in along with the management zone, pre-populating their core sites, marking their cores, sending that off to the lab, all based on that remote sensing data. Over here left, here's a bucket full of cores. On the left, you see a lot of calcium carbonate in here and there. So that was all of those cores collected not randomly throughout the field, but based on imagery, and you'll have bad soil, good soil. So in the second case, it's kind of the second part of the off-season or burn down. A lot of weed pressure, kind of planting date decisions. And just a couple of examples here. Down here on the bottom, there's a missed application path, a bunch of weed pressure down there. Growers may know where that is, but maybe their advisors are, helping them, kind of understand where it is, what's it going to take to deal with it, and so forth, and getting that done before, so they don't have to do a mid-season application. Another example, that is the exact width of an application machine, so you got missed at some point. Being able to document that, make a record of it, and again, it is a report card at the end of the year. I had to go do these things, and this is why, this is what the decision was. The next thing is kind of the planting stage, Some of the challenges are seeding rates, replant decisions, planter performance, just as a few. I have a great planter performance use case, but it's from the United States, so I can't show it, but I think everybody's had their problem days. So here's an example of a seeding prescription. So this was generated from multiple years of imagery. So the idea was, the good years, the drought years, and the average years. Blend that all together so that I have a general idea of where there's high-performing soils and low-performing soils. Build out my seeding recommendation. I get my average number of seeds, min-max, total bags, and then I can send that directly to the planter. We focus on seamlessness, so Slingshot does connect to some planters out there, right? And my John Deere. So the goal is no more USBs wherever we can have it. So this is a great case for using imagery to build a seeding recommendation, automatically building the recommendation, including the advisor into the seeding rates, and sending directly to the tractor and planter for the grower. I took in season and divided it into three areas, kind of early in season, mid, and late. Some of the challenges, again, are weed pressure, flooding, hail, general stand health. And this is kind of where the right tool for the job is where drones really could shine, because the amount of leaf area to soil is really low. There's not a lot of leaf area, and this is kind of where stand counts come in. You take satellite data with D3 corn, and you're not going to see anything. You're just going to see dirt. This is a hail example that I have. So this is a true color image in Argentina. Looks like dirt. You take an index of that and kind of embellish the differences, and you'll see this area kind of a little bit red to the right. And what this grower did is they planted at 32,000, and they basically have a general decision over their farm. Anything below 20,000, and they replant. Anything above that, they let go. So they kind of divided that field up all from the image, and then they said, okay, we're going to go out and check it. So they went out and checked it, and they made the decision, and they went ahead and replanted. And I have the yield data for that, and they made the right decision on that, but it allowed them to kind of do that from afar. They didn't say exactly what they were going to replant, and they didn't make the decision from the image on what was needed to replant. They just told them where. It still took the advisor getting out in the field outside of the truck and working with the grower. The kind of the middle stage of in-season, a lot of crop health and side dress decisions that can be made. So here's just a quick example of, within the same field, what the different areas might be, create observations in there. It becomes a record. Using the imagery to direct where that crop scout is going to scout to kind of understand. We don't know what's happening. We just know that this image on the right is a little bit less than the image on the left. So we got to still get out in the field for that. Third stage of some of the in-season. Now you'll kind of see some yield and management practice evaluation. Scott talked about nitrogen. Stuck nitrate test, right? That's excess nitrogen on the field. And if you start to do some yield estimates, so I kind of call it poor man's yield estimation. It's not the glorious, I can take an image in June and tell you exactly how much and, how much to sell on futures. But you can start to get an idea of what you're doing. So maybe by scouting, you want to go take a look at this area that's of low vigor. And, see there's a guy standing out there, it's below his knees, and he does a yield estimation based on soybeans, whatever strategy he uses. Then goes and finds an area that's a midpoint within that health, about by his waist. And then he comes out and finds the best area of the field, and so that's 64 bushel soybeans right there. So he's kind of got an estimate, and he's got an area. So using that image, he can kind of qualitatively and quantitatively actually, get an estimate for the yield. So he knows that, 65% of the field was approximately 64 bushel, and can start to build a yield estimation map. So just by using the management zones, calculating the amount of area by the estimated yield, they've got a yield estimate for that field. So not automated, but very valuable using the imagery. Finally, kind of harvest. Harvest is kind of an interesting area for, I personally haven't been seeing a lot of value in the harvest area, but I did get some amazing use cases in the weed resistance area. So this would be a soybean field with resistant sorghum. So this grower, this is a huge issue for him, and he was detecting this through imagery throughout his whole farm, and he needed to nail it immediately after harvest. Because if they ran through it, they wouldn't be able to get it, and they'd go to seed and have a huge problem. So they were using imagery pre-harvest when the crop dried down. The resistant sorghum was still going, and they allowed them to go out and put chemical on that and kill it down. So highly concerned, at least in South America, on kind of pre-harvest weed detection so that they can nuke it right after harvest. So that's all I had. Kind of general use cases for imagery. And kind of not really specific to any type of provider, but there's great value, and we've got to get it down to the field as seamlessly as possible. Very good, thank you.
Well, I took a picture of flying the field when you need to fly it, how it's processed, and then ultimately how you can actually make use of that data in your operations. To apply the right product, the right time, at the right rate, at the right place to hopefully increase your yield at the end of the season. With that, we are going to open it up to questions. I know we have a few that have come in online already, and so go ahead and start sending those in. Anybody that's here with us today live, if you guys have any questions you'd like to start us off with, go ahead and throw them out there. I'll pass this back to you.
Okay, I'm sorry. So on a typical flight plan, when the AgEagle goes up and pictures are taken, working with the software, about roughly how many pictures, because I know there's a lot of stitching that goes on. So how many is that, and how is it put together?
Yeah, I mean, it depends on the field. I think we're seeing, on average, a quarter section field is probably about 1,200 pictures to 1,500 pictures. And a lot of it depends on environmental conditions, the winds, and how high you're flying. But usually it's a little around over 1,000.
And to add to that, the sensor that we're using today is a much more advanced sensor than what was used just a year ago. This new sensor that we're using compresses the data. So each image is only about 400 to 500 kilobytes versus a year ago it was around 3 to 5 megabytes. So it's much more manageable data.
So along that line, does collecting the change through the growing season? Sure.
Question. together. However, AgEagle and Botlink uses some newer technology where we measure the inertial data, the coordinates, the pitch, and the roll, and the compass heading during each capture of the image. That's embedded in the image. So the stitching machine uses that to create aerial maps faster and more accurate. But later in the season, when it's just a sea of green, and there's the crop grows really well, and there's a very few unique points, you do have to increase the overlap, sometimes as much as 80, maybe even 85%, because it's a really good field. However, the thing we have to keep in mind, this information is most useful when the plants are younger. And so when they're younger, you still have, you can see the rows, you can see the plants, and you can see the soil. And for those times, you can widen back up. So you're covering a lot more acres earlier in the season when the information is more useful than you do later in the season. You know, after the corn is passing, there's not a whole lot of reason to keep mine other than curiosity.
Right. And Botlink, you want to add anything? Okay. One more in there. So I know with descriptions for satellite imagery, they give you a set number of images per growing season. And we talked a little bit about the AgEagle giving you the ability to control when you take those images. So do you guys have a on when you should collect that data, do those flights, how often? Talked a little bit about maybe just before certain applications. So what are your recommendations on when to collect the data?
This week, 3 different times, or maybe even 4 different times during. Some people use this to see how my plants populate. Do I have an area where I have a node? Then as the application becomes for nutrients, chemicals, herbicides, fungicides, becomes, if they're using it throughout the season, some of our customers are flying the field once a week during the heat of the season to find out what the health is. There may be an area of concern
And to the software providers, do you guys have any recommendations on how often or when that data is more?
And more very, you know, for what I talked about in season. A lot of people, estimation piece, and really what I do agree is more importantly, earlier this season, you are getting stages where you can and try to do something to make an application or turn forward.
Yeah, actually using the data to take some action and make a difference. Great. So questions from the online audience.
We got the first one. You use dry flow that mix in the tank with direct injection. How do you use dry?
So he probably is using mixing in some kind of dry flowable, putting it in the pure form in the chemical injection tank, and then direct injection pump is what I'm gathering. It will depend on the what? Atrex? Okay, specific. That's good to know. Atrex or atrazine would be the chemical that we're talking about here. We have had experience with that specific chemical. We've done that in the past, and the injection pump will pump that chemical. There's a couple things to remember when you are putting chemicals such as that. They tend to settle. So if you are putting them in their mixed and pure form in an injection tank, you still must find a way to agitate, and we do provide an agitator that can be put on that pure chemical tank that feeds the injection pump. From there, we have experience, and we have not had issues with pumping something like Atrex or atrazine going through the pump. That being said, we do have to know our chemicals. So we have a chemical that has a wettable powder or something that can be somewhat chalky, thicker in substance, higher in viscosity. That also means that the pump itself has to be maintained. For something like that, we would recommend at the end of each day of use that you do flush the pump out, probably with a water-based product, just to make sure that the chemical itself does not reside or collect inside the injection pump. Yeah, I would. Just to make sure. That was made. There are two forms. I mean, there's a liquid and a dry wettable powder form. If he puts it in the tank, he has to obviously mix it in the water form to make sure it's soluble at that time. And from there, we still need to agitate it though, because it will tend to settle. So we need an agitator that can be an additional add-on to that tank to keep that suspended in animation.
Eagle. The first one, if there are tall trees at the edge of...
So, tall trees around the field. So the AgEagle by default is flying a pattern of 400 feet over the launch point. Typically, trees are not a problem. Typically, tall power lines are not a problem. So the drone's just going to go over the top of those areas, and it would include it into the map. So at the conclusion of the flight, once the data, the map is processed, you would then clip that field to the boundaries using your preferred farm management software, clip out that other vegetation, and most people would want to even clip out the waterways to make it more accurate as well. So trees and power lines are not a problem. Did I address that question properly? Power transmission lines did cause issues about 5 years ago when we first started this technology. However, in the last 3 years, we have conquered that. In the AgEagle, it's using a sophisticated flight management system, meaning that there's 2 GPS systems in there, one more advanced than the other is more of a backup. It's receiving all 3 constellations, also from the U.S. GPS constellation, the European Galileo, and the Russian system as well. So it has a rock-solid navigation system on it, and flight over transmission lines not a problem. We've flown over 72,000-volt lines all the time with no issues.
The second question for AgEagle. Can the AgEagle platform successfully fly in temperatures greater than 80 degrees without flight time degradation or lipo damage?
So, temperature the flight time on the batteries. What will destroy the batteries the quickest is leaving them in the sun and allowing them to get too hot. or over discharging. However, under flight, they're being cooled by the air that's going over the drone, and that's really not an issue. This summer, we recorded temperatures of 105, 106 degrees inside the cockpit of the drone, and we did not notice any significant difference. Now, in the controversy, if it's below freezing, there is an issue, but most of our customers are not using below freezing.
Perfect. And the last question we have from online is for all presenters. Do you see the wide array of moving parts, various subscription models in the process of using UAS to make field application decisions as a barrier to entry for potential customers right now? It still seems like a complicated process end-to-end in 2017.
I would say that is rapidly changing. It's part of the reason for this meeting here today is to offer a complete solution. Yes, there are various tools that can be used, but today we're going from flight to processing to importing all automatically. So the technology's come a long way. But in the early days of this technology, which was about 2 or 3 years ago, when people had to buy a $10,000 water-cooled computer and install Russian software that was not very friendly, it was a big turnoff for this technology. Other presenters? Oh, yes.
Yeah, and then that's really what our main focus is as well. You know, along with everyone else here is we've connected with both AgEagle, so Botlink is optimized for the AgEagle system to easily when you set up your AgEagle, that's all within Botlink. And then our integration with SST is really addressing that as well as so you're not having to upload images, download images, upload images, make a bunch of different file format changes. So you can set up with a program like SST, so when you fly with Botlink and upload images with Botlink, that process imagery is automatically sent to SST, so you don't need to do any kind of moving files around and trying to manage your data.
I just kind of go off that comment, Nick from Agrian, and seamlessness is the word of the day. Basically, it's pretty much unacceptable for anything to be moved manually. A farmer should not know image file types, projections, or anything like that, even advisors. So as a kind of a group, as an industry, we have to ensure that we go for seamlessness wherever we can. Otherwise, it will just stay with the innovators and never get to the pragmatics. So.
And I'll add one note on that. Well, I do work for Raven. I don't work for AgEagle or Botlink or the other software companies, but I have been a user of this technology for, like I said, for the last year and a half. And the improvements that have been made in that short period of time have really improved the seamlessness of using this technology from flying the drone to automatically uploading the imagery to Botlink to having it stitched together behind the scenes. You don't see it happening, but within an hour it's there. And then being able to transfer that finished image and that data into various software packages to have it processed and produce your prescription maps. So that has drastically improved, and it's only going to get better as things move forward. Other questions? Anyone online, Travis? Okay. Any more from the group here in Sioux Falls? We've got a pretty diverse group in here today, from turf management to farmers to software to anything you guys have.
One of the questions is, does the AgEagle require cellular or internet connection to fly? No, it does not. We use an Android tablet to keep it simple to create the flight management through Botlink app. The only time you have to have internet is if you want to prefetch the background maps on your Android tablet, so when you're going to an area, you don't have to connect to the internet in that field to create the flight plan. the cellular connection is optional to upload the images. So there is a cellular modem built into the drone, and while the drone flies, it's uploading the images automatically. And when you get back to the office, you have a high precision map already created. So no, it's not required, but it's optional if you want to turn it on.
All right, thank you, Brett. I'll throw it out one more time for anybody here in Sioux Falls with questions. We will, if you're online and you do have questions that maybe come up after you finish the event, please submit them to us. We'll certainly collect the information from the various groups here today and get that information back to you. A few comments on closing. Participation or attendance at this event today does qualify you for some special programs with all of our RavenX events. Now, RavenX events are not just held in Sioux Falls. We travel around the United States and we hold various events featuring different products, different agriculture products or Raven products throughout the United States. And with all of those events, we do offer a 5% discount on any products that you purchase after that event. And also, Raven does offer a 30-day proof of purchase for any of our products. So you purchase a product, you operate it, you try it, you use it for 30 days. If you're not satisfied with it, you can return it and get your money back. So those are a couple of programs that are available to you for attending a RavenX event today or any events around the country. In addition, AgEagle has a special that they're running to tie in with this event. If you do purchase an AgEagle 48 by the end of August, you will get one additional battery that you can use with the system, and you will get a second battery charger that can charge up to 4 batteries at one time. So a very useful tool if you're going to be flying this on a daily basis or multiple flights throughout the day. You need good batteries charged up, ready to go for the system. So a great deal that AgEagle is offering us. Throughout the event, I've been monitoring the weather, and unfortunately, we still have a shield of rain around us for about a 45-mile radius. So I don't see that we're going to be able to do the live demo of the AgEagle today. But as I mentioned, we do RavenX events throughout the country, and we do take the AgEagle with us. So watch our events page for events that might be coming into your area. If you would like to see a demonstration of the AgEagle and there is not an event scheduled in your area, please contact us. We will be sending out a small survey after this event. And you can add your comments, you can answer our questions. We will have contact information in there. So if you are interested in purchasing an AgEagle or more information on any of these products that we talked about today, certainly let us know through that. Like I said, we will be offering these specials throughout the end of August on the AgEagle. We'd love to get one in your hands, get it in the air, and you can see how successful it is in collecting the data, and then how useful that data is in managing your farms. So with that, I guess since we're not going to fly today, Brett, do you want to give a brief description of prepping the aircraft and doing a flight? What we can in the room, and then we'll kind of wrap up for the day.
Sure, it's very simple to prepare the drone for launch. The battery goes in the front bay here. You operate it, of course, with a fully charged battery. It takes about an hour to charge the battery, and with your Android tablet, you turn it on, and your Android tablet has a map showing where you are at in the field. And you just literally click on the tablet around the map, and it creates your flight plan automatically. More importantly, when you create the flight plan, you tell the tablet which way the wind is blowing from. So when you do that, the drone will then fly into the wind. It makes all of its turns into the wind. And you also tell it where you want it to land. And it's just drag and drop on the tablet. So once you have the flight plan created, you arm the aircraft, and you pick it up and shake it, like the video showed, and it takes off, and you just watch it on the tablet. So it's very, very, very simple. If the battery goes dead while it flies, or it wasn't fully charged, the drone will come back and land before the battery is totally exhausted. If the Android dies or the battery goes dead in the Android, the drone keeps doing what it was last told to do. And it will do the mission and come back and land all automatically. So there's a lot of fail-safes in it. Does that cover what you wanted to cover?
All right. Again, thank you, everyone, for participating. The people here in Sioux Falls, I appreciate you coming out and joining us on such a lovely rainy day in South Dakota. And for those of you online, thank you for joining us. And be sure to look for that survey and get the information back to us. And again, if you have any questions after the event,